What's up, guys? This is FTC Loose Screws 22012, and this is the third part of our series of AprilTags. Just for a recap, in the last video we covered yaw, pitch, roll, range and bearing, X, Y, and Z, and AprilTag ID. And you can watch the last video if you're unfamiliar with any of these. And here is a diagram. So here, this blue thing is the AprilTag. This point right here is the center of our camera. This arrow right here is our range, and this angle is the bearing, and this angle is the yaw. And we can show our bearing for B and yaw for Y. And doing some basic math, we can see this angle right here is 90 minus B because we have a right triangle right here. So this total angle right here is 90 minus B plus Y. So now if you look at the field, we can see our AprilTag, and we can see a robot here. We can see the range, and we can see this angle right here. So doing more math, we can see this is B minus Y because this is a right triangle. And we can see this is our cosine B minus Y, and this is our sine B minus Y. So how can this help us in a real match? So let's say if the center of our AprilTag is X, Y, and we know the distance, the X distance and Y distance from the AprilTag, we can find the position of the camera by using X minus R cosine B minus Y and Y minus sine of B minus Y. But keep in mind, this only works if the camera is at the same Z level as the center of the AprilTag, which means if the camera is too high or too low, it could skew our data and make our position of the robot inaccurate. So in code, it looks like this. So we define a double theta to be equal to the bearing minus the yaw. And we can define change in X to be R times the cosine of theta, and change in Y to be R times the sine of theta. And we can denote camera X as the position, the X position of our AprilTag minus the change in X, and Y to be the Y position of our AprilTag minus the change in Y. And some future uses of this, you can try to do this for all tag IDs, not just the top right. And you can try to find the position of our robot based on the position of the camera. And that's it.